In this course, when we talk about sequences, we generally classify them under one of two types. We're either working with an arithmetic sequence or a geometric sequence. So we'll save our next lesson for geometric sequences, and today we'll focus on arithmetic sequences. So what makes an arithmetic sequence an arithmetic sequence? So let's take a look. An arithmetic sequence can be written as A plus D, A plus 2D, A plus 3D, and so forth and so on. And A is the value of the first term, and D is the common difference. And what is the common difference? It's the difference between any two consecutive terms in an arithmetic sequence. So you've already seen arithmetic sequences before, you just didn't know they were called arithmetic sequences. And if you look at this pattern, A plus D, A plus 2D, A plus 3D, it's very much like what you did in grade 9. It follows like a linear relationship. But remember, you don't have a continuous function here. When we talk about sequences, we're talking about discrete functions. So we want to generate a formula, or like an explicit formula, that's going to help us find the value of any term. And we call this formula the formula for the general term. Anyways, let's take a look at the terms, and we should be able to come up with a formula here. So to find the second term, you add by 1D. To find the third term, you add by 2D. To add the fourth term, you add by 3D. So hopefully you notice that the multiple of D's which you add by is always one less than the term number. So the nth term, the general term, could be found by taking your first term and adding by n minus 1 D. Okay, one less than the term number. That's what n minus 1 means. Just like when you are working with recursive sequences. And of course, n is a natural number. All right. So let's take a look at example 1. For each arithmetic sequence, determine the value of the first term and the common difference. So this one's pretty straightforward. A is equal to -4 and D is equal to +4. Because if you look, they're going up by 4. Okay, terms are going up by 4. For the second sequence here, the first term is 2 and the common difference is 3. They're going up by 3. All right, for this one, the nth term is equal to 2n plus 3. You might be tempted to say that the first term has a value of 3 because you're thinking back to grade 9 and y-intercept, but if you actually do the math, use the formula for the general term, you'll see that the first term is not 3, but it's actually 5. You could find the second term to solve for the common difference, but if you imagine like 2 here, that's our slope, right? That's telling us how the values or how the terms are changing. So if the slope is 2, then you can imagine that the next term will be 7, and the one after is 9, and then 11, because they're going up by 2. So that must be the common difference. So A is equal to 5 and D is equal to 2. All right, let's take a look at our next sequence here. Is this sequence arithmetic, and how do you know? Yes, because there's a common difference of -6. Okay, if there's no common difference, then it's not an arithmetic sequence. It's very easy to spot an arithmetic sequence. It's probably, I can argue that it's the simplest relationship. All right, so let's find the explicit formula for the general term. All right, so T sub n equals A plus n minus 1D. So if I want the formula, I need A and I need D. So I know A is -13 and D is -6 based on the sequence. So -13, -6. Of course, we're going to simplify this. So therefore, let's write it nicely here. Okay, the nth term is equal to -6n minus 7. N is a natural number. Always add that, okay, because it goes from continuous to discrete. And that's what we're focusing on this unit. All right, what's the value of the 15th term? No problem. Let n equal 15. So that's negative 97. All right, they want a recursive formula. We can do that too. So to find the nth term, you take the previous term and you subtract by 6. Oh, don't forget, a recursive formula, you have to spot the person, the first term. The first term is negative 13. And then, of course, natural number, and n is greater than 1. Okay, let's do a few more problems. I'm told that the 11th term is 72 and the 21st term is 142. What is the value of the 195th term? Okay, all right. So there's actually, I would argue, quite a few ways to do this. The textbook does it one way, but it's not the most efficient way. So I'll show you the most efficient way and then I'll show you the textbook way. All right, so if they tell me the 11th term and they tell me the 21st term, I can actually solve for the common difference rather easily by understanding how an arithmetic sequence works. So the 21st term and the 11th term, what's the relationship between the 11th term and the 21st term? Well, to go from the 11th term to the 21st term, I add by 10 times the common difference. It's like when I think of an arithmetic sequence, I think of a train. Like I'm going from one bus stop to another bus stop to another bus stop until I reach the destination I want. So anyways, I'm on the 11th term. I need to get to the 21st term, so I add by 10 times the common difference. Since I know the 11th term and the 21st term, I can solve for the common difference rather easily. Okay, so let's subtract 72 to both sides. So d is 7. Perfect. And now I want to find the 195th term. I could use the 11th term or the 21st term. Doesn't matter. I'll use the 21st term. So the 195th term is equal to the 21st term plus, well, the question is, how many d's should I add by? What multiple of d? How many bus stops will it take me to get there? 174. So since I know what d is and I know the 21st term, this one shouldn't be too bad. So 21st term is 142. And the common difference is 7. So, perfect, 1360. All right, so that to me is the most efficient way of doing it. Now, the textbook way is they build a linear system. Nothing wrong with it, but probably not the most efficient. So they say that the 11th term is a plus 10d, which is true. So 72 equals a plus 10d. And the 21st term is a plus 20d, okay? And then that means 142 equals a plus 20d. Guess what? Like I said before, we can build a system. I'm going to solve by elimination. I'm going to solve by elimination. I'm going to eliminate a. And then if you eliminate a, you can solve for d. And guess what? D is just like what we had before. Now we really don't need a, but like the textbook likes to solve for a, so why not? Let's solve for a. Like, if you think about it, you don't really need the first term. All right, let d equal 7 for equation 1. So that means 72 equals a plus 10 times 7. So a is equal to 2. So I have the first term, I have the 7th term. So I can find the 195th term. So t sub 195, the 195th term is equal to a plus 194 times 7, which is 1360. So either way, you'll get 1360 as the value of your 195th term. Okay, but I really want you to understand, if you understand how arithmetic sequences work, you know, there are many times where you don't need to know the value of the first term. Okay, now sometimes you might need to know, but in this case you definitely don't. All right, moving on. An opera house has 27 seats in the first row, 34 in the second, 41 in the third, and the last row has 181 seats. Okay, all right. So you can visualize this as a sequence. And they want how many rows? Well, to find out how many rows is basically how many terms are in the sequence. The number of terms corresponds to the number of rows in the opera house. So let's tell ourselves A is 27, D is 7. Okay. So you know that T sub n equals A plus n minus 1D. So I want to figure out the term number here. So I'm going to sub 181 as T sub n, 27 is A, n minus 1 times 7. You know what? That's a linear equation. That sounds very easy. So you know what? Subtract both sides by 27. So you got 154. Divide both sides by 7. And then add 1 to both sides. So n is 23. Therefore, there are 23 rows. Okay. Alright, so let's see. How many multiples of 4 are between 11 and 151? Okay, well, the first multiple is 12. The second one is 16 and then 20. The last one, you can use a calculator and check, but it's 148. So now we basically converted this question just like what we have before. How many terms are there? Because the number of terms will tell me the number of multiples between 11 and 151. So same thing. This time I'm just going to just go straight into it. 148 equals, so it's A plus n minus 1D. And D in this case is not 7, but it's 4. So subtract both sides by 12. Divide both sides by 4. It's 25 plus 9 is 34. And then n is 35. Let me just triple check. Perfect. Therefore, there are 35 multiples of 4 between 11 and 151. Okay, so hopefully you have a better understanding of arithmetic sequences. And if you're ready, we can move on to geometric sequences.